All right, let's jump right in. Today, we're going to talk about something so fundamental we barely even think about it: our planet's water system. This silent, life giving network that we all depend on. But here's the thing: it's under some serious stress, and the consequences, well, they're starting to affect all of us. So, to really get a handle on what's going on, just think about this for a second. What if our planet's plumbing just broke? I mean, seriously, what if the pipes bringing you fresh water suddenly started bursting in some places and then running bone dry in others? It sounds dramatic, right? But in a way, that's exactly what we're looking at. Okay, so here's how we're going to tackle this. We've got 5 key parts. First, we'll look at the planet's plumbing system itself. Then, we'll get into this growing imbalance between what's coming in and what's going out. After that, we'll see how our water reserves are draining away and why that's leading to extreme floods and droughts. And finally, we'll connect all the dots and talk about the huge ripple effect this has on our water security. All right, let's kick things off with Section 1, the planet's broken plumbing. Because, before we can understand why it's breaking, we gotta have a solid idea of how this whole system is supposed to work in the first place. So the official name for this is the hydrological cycle. It's basically the continuous, massive movement of water on, above, and below the Earth's surface. And that plumbing analogy we mentioned, it's honestly perfect. Think of it as this huge, intricate network of inputs, outputs, pipes, and storage tanks, a system that has, for thousands of years, worked just beautifully. But, and this is the absolute crucial point, that finely tuned system, it's being thrown way off balance. It's being disrupted. And the force behind that disruption, it's climate change. It is fundamentally rewriting the rules for how this entire global plumbing network operates. So that brings us to Section 2. Let's build on that idea. We're going to look at what you could call the taps and drains of this whole system, the inputs and the outputs, and really dig into why they're falling so out of balance. Okay, this really gets to the heart of the physics here. It's pretty straightforward, actually. First up, a warmer atmosphere can just plain hold more moisture. It acts like a bigger sponge. For every single degree Celsius of warming, the air can hold about 7% more water vapor. Then you've got higher temperatures, which means more evaporation from oceans, lakes, rivers, you name it. That just loads even more moisture up into that atmospheric sponge. Put those two things together and bam, you're fundamentally changing rainfall patterns across the globe. And this is where we get this crazy paradox. The changes aren't happening evenly at all. What we're actually seeing is this amplification of the extremes. So places that are already wet, they're getting absolutely hammered with more intense extreme rainfall. And the dry regions, they're getting even drier, leading to longer and more severe droughts. It's a world of haves and have-nots when it comes to water. Okay, so moving on to Section 3. It's not just about the water coming in from the sky. We also have to talk about where we keep it. Think of them as the planet's giant water towers or, our global water savings accounts. These are our critical water stores. And just take a look at what's happening with glaciers. It's this really clear 4-step process. First, temperatures rise. That, of course, makes the glaciers melt faster. Now, in the short term, all that extra water has to go somewhere, right? So it pours into rivers, which can seriously increase flood risks downstream. But, and this is the kicker, in the long term, that giant frozen reservoir is just gone. And that means a permanent drop in the water supply for literally millions of people who rely on it year after year. And hey, it's not just the glaciers. This slow drain on our planetary savings accounts is happening across the board. You've got permafrost thawing and releasing water that's been locked away for centuries. You've got the moisture in our soil, which is absolutely vital for growing food, just evaporating into the thin air. And we are pumping out groundwater from underground aquifers way faster than nature can possibly refill them. So all of this leads us right into Section 4, extreme flows. I mean, it makes sense, right? When you mess with the inputs, the rain, and you drain the storage tanks, you are going to create absolute chaos in the pipes. And in our analogy, the pipes are the planet's rivers. And what that chaos looks like is this. Our rivers are becoming so much more volatile. They're swinging wildly and really unpredictably between two extremes. On one hand, you have devastatingly high flows that cause massive floods. And on the other, you have critically low flows that lead to droughts. Trying to manage water in a world like that, it's becoming incredibly, incredibly difficult. But wait, there's more. There's another factor here, a kind of wild card in the whole climate system that takes all of this unpredictability and just cranks the dial up to 11. So, what is it? It's a little thing called ENSO. You've probably heard of its two phases, El Niño and La Niña. Essentially, it's a totally natural warming and cooling pattern in the Pacific Ocean that creates these massive domino effects on weather all over the world. But here's the problem. This natural cycle is now playing out on a planet that's already warmer to begin with. And that interaction is like pouring gasoline on a fire. It's supercharging the droughts and floods we're already seeing, and it's making an already unpredictable system even more chaotic. Okay, which brings us to our final and honestly our most important section, the ripple effect. We've gone through the science, so now let's bring it back to the real world. Why does any of this matter? What does it mean for our water security? So, when we say water security, what are we even talking about? Well, it's a really simple but incredibly powerful idea. It's having reliable access to enough clean water for our health, for our jobs, for our entire economy. It's really the foundation of a stable society. And when that foundation starts to crack, the consequences are, well, they're severe. This is what's at stake. We're talking about the water supplies for our huge growing cities. We're talking about global agriculture, the system that feeds billions of people. And we're talking about the very real potential for conflict as this precious resource becomes more scarce and unpredictable. The research on this is crystal clear. It puts it pretty starkly, actually. These changes, and I'm quoting here, pose significant challenges for the future of global water security. This isn't some far-off, distant problem. It's a clear and present challenge to the stability of our world, right here, right now. And all of that leaves us with one final, absolutely critical question. We are moving into an age of water uncertainty, an age of extremes. So the real challenge for every single one of us is this. How do we prepare for both the flood and the drought when they might be happening in the very same place?